This standard is about dividing polynomials. We're going to learn two different kinds of polynomials that we can divide. One is if you divide it by a monomial, and the second way is to divide it by a binomial. And we'll use long division, a technique similar to how you divide big numbers that are just regular numbers, not with variables or anything. So let's start with this first one. Here's a polynomial, a third degree trinomial, 10x to the third minus 4x squared minus 5. And I'm going to divide that by a monomial, 2x squared. So what you do is you think of this as having three separate parts. It's sort of like the distributive property a little bit for dividing. So the 2x squared has to go with that one, and the 2x squared has to go with that one, and the 2x squared has to go with that one. So I'm going to write this as three separate terms. I'm going to write 10x to the third divided by 2x squared. So that's my first little red circle. And then subtract, because I had a minus in front of the 4x squared. 4x squared over 2x squared. And then for my third little circle, it's subtract again, 5 over 2x squared. So now I'm going to have to divide each of these similar to how we divided back in the exponent rules section. So 10 divided by 2, that's 5. X to the third over x to the second. So 3x's on top, 2x's on the bottom. That leaves me with just 1 on the top. Minus 4 divided by 2 is 2. X squared over x squared, that cancels out, so there's no x squareds left. And in this last one, there's no x's on the top and just an x squared on the bottom. So I'm going to leave that just like it is, minus 5 over 2x squared. Next, we're going to divide a polynomial by a binomial. And when we do this, we're going to use a technique really similar to long division with numbers, like I just said. So let's just review how you do that, because I have a feeling a lot of you might have forgotten that. So let's try 385 divided by 6. So the first thing you ask yourself, does 6 go into 3? No. Does 6 go into 38? Yes. How many times? 6. Because 6 times 6 is 36. And you put the 6 over top of the 8, because 38 is the number it went into. 6 times 6 is 36. So you're going to subtract those. 38 minus 36, that's 2. And you bring down that 5. 5. So now how many times does 6 go into 25? 4 times. 4 times 6 is 24. Subtract again. That's 1. There's nothing to bring down, so that means there's a remainder of 1, which you write as a fraction. 1 over, and the 6 you were dividing by. So 64 and 1/6. So let's try that technique over here. It's not exactly the same, but it's pretty similar. We're just going to look at this x in the front. We're going to ask ourselves, how many times does x go into 3x squared? And the answer to that is 3x, because 3x times x would be 3x squared. And I'm going to put that 3x over top of the 5x. It's kind of like it's the x place. So if x is the variable you end with, it goes over top of the x. So 3x times x is 3x squared. Same as that, but it should be. That's how we picked it. And now you have to multiply the 3x by this 4 that's over here. So 3x times 4, that's plus 12x. And then I'm going to subtract, and I have to subtract this whole thing, so I'm going to put parentheses around it to remind me of that. So these guys cancel out. Negative 5x minus 12x, that's negative 17x. Now I'm going to bring down the plus 2. How many times does x go into negative 17x? It goes in negative 17 times. So there's negative 17x. And then negative 17 times 4, that's negative 68. So once again, I'm going to subtract the whole thing. These guys cancel out. 2 minus negative 68, that's 2 plus 68, or 70. So the remainder is 70. And I'm going to put it over top of x plus 4. Same as we did over here, it turned into 64 and 1/6. This turns into 70 over the thing you were dividing by, x plus 4. Now we're going to divide by another binomial, but this binomial is a little more complicated because it has this 2 in front of the x. Also, I've written it in a different form. I've written it out as a division problem in a fraction, But we all know that a fraction is the same as a division problem. So I can rewrite this problem as 4x to the third plus 8x squared minus 3x plus 1 divided by 2x plus 3. Alrighty, so how many times does 2x go into 4x cubed? 2 times 2 is 4, so I'm going to have a 2 in front. And x times what is x to the third? That would be x to the second. So 2x to the second is what I need to put on top, and I put that in the x to the second place. So 2x to the second times 2x, 4x to the third, 2x to the second times 3, plus 6, because 2 times 3 is 6, x to the second. Subtract that whole thing. So these are gone. 8x squared minus 6x squared is 2x squared. And then bring down this minus 3x. Alright, so how many times does 2x go into 2x squared? That's just going to be x times. So x times 2x is 2x squared, and x times 3 is 3x plus. Subtract that whole thing. These guys are gone. Negative 3 minus 3, that's negative 6x. And then bring down the 1, plus 1. How many times does 2x go into negative 6x? It goes in minus 3 times. So minus 3 times 2, minus 6x. Minus 3 times 3, that's minus 9. So subtract that whole thing. This is gone. 1 minus negative 9, 1 plus positive 9. So the remainder is 10. And I'm going to put that remainder here, plus 10 over the thing I'm dividing by, 2x plus 3. So the answer is 2x squared plus x minus 3 plus 10 over 2x plus 3.